All right, good evening, everyone. Hope all is well. Hope everything's going all right. So, today we'll get into what you did 1, 2 last class. So we'll look at, is it 1, 2? No, 2, 1. So we'll at least look at 2, 3 and go from there. Not, yep, no, 2, 2, and then go from there. 2, 3, we're actually not doing. So before we do anything, anybody have any general questions or anything before we get rolling? All right. So 2.2 limits of functions and limit laws. Hold on 1 second. All right. So when we talk about limits and the limit of a function, talking about how a function behaves near a particular point, but not necessarily at that point itself. So you see what I mean as we get into it, but uh, how a function behaves at a particular point or as it near a particular point, but not necessarily at that point. So as it goes toward that point, how is the function behaving or what point is the function going to? I could have wrote this stuff a lot better, but all right. So some of them will be very simple. In other words, when you plug in a value, it'll just be plugging in the value. So in other words, here it says find the limit, and we have x to the fourth power plus x squared minus 1 over x squared plus 5. So we want to find the limit of this function as x goes to c. So all we would do is plug in c, and that'll be c to the fourth plus c squared minus 1 over c squared plus 5. So nothing else we would do to that. We don't even know what c is, but we just plug in the value of c in for x. All right. Any questions on that? All right. So the next one, we want the limit of the square root of 4x squared minus 3 as x goes to -2. So keeping in the same thought process of how we plugged in the c for x, we'll plug in -2 for x. So that's 4 times -2 squared minus 3 under the square root. -2 squared is 4. 4 times 4 is 16. 16 minus 3 is 13. So that'll be the square root of 13. All right, any problems, any problems? All right. Next one, we have the limit of x squared plus x minus 2 over x squared minus x as x goes to 1. So just like before, we'll take what x is approaching or what x is going to, plug it in for x into the function. So it'll be 1 squared plus 1 minus 2 over 1 squared minus 1. So of course, 1 squared is 1. 1 plus 1 is 2. So 2 minus 2 is 0. On bottom, we also have 0. So 1 minus 1. So this is not a good situation for us to be in. 0 in your denominator is undefined. So that's never a good place to be. So that means we need to manipulate the problem in some way in order to be able to get an answer. So if we actually go back and factor our numerator denominator, we see that we have x plus 2 times x minus 1 in the numerator. Then in the denominator, we were to pull out x, factor out x, that'll be x times x minus 1. And we see we have x minus 1 in common with the top and bottom, so we can cancel out that quantity in the numerator and denominator. And now that leaves us with x plus 2 over x. All right. All right. So now we can evaluate this limit as x goes to 1. X plus 2 over x, plug in 1. So it's 1 plus 2 over 1, which would be 3 over 1, and simplifies to just 3. So if plugging in a value for x initially creates a compromising situation like 0 in your denominator, then you have to go about some other means to find an answer for your limit. All right. Any questions so far? All right, so here we have the limit as let's go to 0 of the square root of x squared plus 100 minus 10. So notice the minus 10 is on the outside of the square root, and it's over x squared. Now, once again, we have a situation where if I put 0 in for x, or put what x is approaching in for x, in this case, it is 0, that will create 0 in our denominator. So we have to do something in order to counteract that situation. So in this case, I can write this a little better. Multiply the top and bottom by the conjugate. I should say conjugate of the numerator. All right, so when we talk about conjugates, everything is the same except for that middle sign. So we had the square root of x squared plus 100 minus 10. So we're going to multiply top and bottom by the square root of x squared plus 100 plus 10. So we're going to just change that sign that's in the middle. And remember, you can manipulate problems or manipulate fractions as long as you multiply the same thing to the top and bottom. So it keeps your equivalency. All right, let me. All right, so that's what we're doing right here. We're going to multiply, like I said, the top and bottom by the conjugate of that numerator. All right, so in the numerator, we're going to fall out the square root of x squared plus 100 times the square root of x squared plus 100. Let me erase some of these slashes. So that's going to be the square root of x squared plus 100 squared. Because remember, whenever you multiply something with the radical, in other words, if I multiply the square root of 2 times the square root of 3, that would be square root of 6. So you just multiplying what's under the radical and leaving the radical. So we multiply these two quantities to each other. So it's just x squared plus 100 squared. All right. Then the square root of x squared plus 100 times 10, that's here. Negative 10 times the square root of x squared plus 100 is right here. And then negative 10 times positive 10 is negative 100, which is right here. All right. So now the square and the square root will cancel, just leaving you with x squared plus 100. This quantity of 10 times x squared plus 100 will cancel out with the minus of 10 times x squared plus 100. And then that'll leave you with this minus 100 back here. So make sure we're okay with the cancellations. All right. And then to finish it off, 100 minus 100 cancels, and that'll leave you with just x squared for your numerator. Remember, that was just breaking down or simplifying the numerator after we did our multiplication here. All right, so now in our denominator, we could have just divided it up a little bit. In the denominator, we don't have to necessarily FOIL that out. All I did was multiply x squared times this quantity right here. So just x squared parentheses, square root of x squared plus 100 plus 10. And so you'll see why I didn't distribute that in a second. But this is our new expression, x squared over x squared times the square root of x plus 100 plus 10. So let me write that a little better. So this is our new expression. And now we see the x squareds can cancel. And that leaves us with, this is our latest way of expressing what we had originally. And now we can go ahead and plug in 0 for x to get a value. All right, so before we go any further, questions on anything that we've done up to this point? All right, so now plug in 0 for x. And so that's 1 over 0 squared, or square root of 0 squared plus 100 plus 10. And of course, 0 squared is just 0. So it's 1 over the square root of 100 plus 10. Square root of 100 is just 10. So 1 plus 10, 1 over 10 plus 10 is 20. So that would be our limit as x goes to 0. 1 over 20. All right. Any questions? All right. So the next one, we have the limit of the square root of 12h plus 1 minus 1 over h as h goes to 0. So once again, we have a scenario wherein if I were to plug 0 in, I'm going to get 0 in for h. I'm going to get 0 in my denominator, which is not a good look for us. So once again, we have to manipulate the problem in such a way that when I plug 0 in, I'm not going to get an undefined calculation or undefined situation. So once again, we have this scenario or the option of multiplying top and bottom by the conjugate of the numerator. So we're going to do that, multiply top and bottom by the square root of 12h plus 1 plus 1. And that's what I did right here. So we'll have to simplify this numerator. And then once again, this denominator I can leave just like that, because hopefully I'll be able to cancel out this h. All right. Try to write this stuff out a little better. I think I was a little sloppy the first time I wrote it. All right, so for do our distribution, square root of 12h plus 1 times the square root of 12h plus 1 would be the square root of 12h plus 1 squared. Then the square root of 12h plus 1 times 1 is just the square root of 12h plus 1. Then negative 1 times the square root of 12h plus 1 is right here, minus square root of 12h plus 1. And then negative 1 times positive 1 is negative 1, which is back here. All right, so simplifying that square and square root will cancel, leave me with just 12h plus 1. And then the square root of 12h plus 1 minus square root of 12h plus 1 will cancel. And then minus 1 is right here. So to finish it off, we see that 1 and negative 1 will cancel. And that leaves me with 12h in my numerator. Any problems? Any problems? All right. So 12h is our numerator. H times the square root of 12h plus 1 is that denominator. So h can cancel. And then 12 over the square root of 12h plus 1 is my new expression. All right. So now we evaluate 12 over the square root of 12h plus 1 as h go to 0. So we go ahead and plug in 0 for h. So of course, 12 times 0 is 0. And so that's just the square root of 1 plus 1 in the denominator. Square root of 1 is 1. 1 plus 1 is 2. 12 over 2 give us 6. All right, any questions? Any questions before we go to another one? Just want to make sure you see different scenarios. All right, so here we have the limit of 1 over c minus 1 over 2 over c minus 2 as c goes to 2. And we see that if I were to plug in 2 right here for c, 2 minus 2 would give me 0 in that denominator. And so we do not want that. So we're gonna have to manipulate the problem in some kind of way in order to prevent that scenario or that situation. All right, So what we're gonna shoot for is to try to at least eliminate the fact that we have multiple fractions going on. So we have fraction here, and then the whole thing is a fraction. So it's considered a complex fraction. So what I'm gonna do is multiply each numerator by the LCD, which is 2c. All right. So we just had a 2 and a c. So we multiply each numerator by the 2 and c. Or if you want to look at it the way of multiplying the big fraction, because we have a small fraction here, and then this is the big fraction, the whole fraction. So we're multiplying the top and bottom of the whole fraction by 2c, which means we'll have to hit each numerator. So see how we got 2c, and I probably want to go purple here. So I'm going to take this 2c and multiply it here and here. And then this 2c needs to be multiplied to each term in our denominator. So c's cancel here, 2's cancel here. And what I have is 2 minus c over 2c times c minus 2. All right. So what we can do now is recognize that there is a relationship here between 2 minus c and c minus 2. If I were to rewrite the numerator with c first and 2 behind it, that's what I did right here. That's negative c plus 2. So this is the same expression. My c is negative, my 2 is positive. And so I recognize that each one of the symbols here are opposite each one of my symbols here. So in other words, I have a negative c, positive 2, and negative 2 as far as comparing numerator to denominator. So if I ever have that situation, then I can just factor out a negative 1. That's what I did here. If I pull a negative 1 out of each one of those terms, then that will give me c minus 2. And then that allows c minus 2, the quantity of c minus 2 to cancel. And now I'm left with negative 1 over 2c. So all of this is just manipulating the problem algebraically before we actually, implement calculus procedures. All right, any questions before we keep going? All right, so now we will evaluate the limit as c goes to 2 of negative 1 over 2c. So now we can plug in 2 for c, which is what we're doing here. So negative 1 over 2 times 2, which would be negative 1/4. All right, any questions? Any questions? I think that's the last one for 2-2. Yep. So any problems before we go to 2-4? All right. Can I hit 2-4? Anybody still copying? Good to go. All right. All right, so 2, 4, still dealing with limits, but we're looking at one-sided limits. In other words, as you approach a point from the right side, or you may approach a point from the left side, how is the graph behaving? So if the limit f of x goes to c exists, then f of x must approach the same point as it goes towards c from either side. So if you're talking about the general limit, what we just finished doing in the last section, the only reason that would exist is if your graph is approaching that point and from both sides. Now that limit does not exist if your graph, and I'll show you examples in a second. And let's say if I have my graph, if my graph is coming up here to this point and then down here from the left side is going to another point. So that graph exists or that limit exists if they're going to the same point. So they have to be going to the same point in order for the general limit to exist. But sometimes that's not the case. So that's why we have the option of coming to or approaching a point from the right side and then approaching the point from the left side. And so that's what we're about to get into. And that will be your one-sided limits. All right. So that's also called a two-sided limit. That, like I said, that's what we were doing in the last section. Just a general limit. It's also called a two-sided limit. If they don't approach or do not approach the same point, then the general limit does not exist. All right. Everybody good? All right, so your right hand limit or right side limit, that's approaching the limit from the right. That's what this symbol, the plus sign on the right side of your number would mean. And then left hand limit, that would be the limit coming from the left. And that's what a minus sign on the right side of your limit or the right side of your value means. Normally, just keep in mind, if I have -2, normally the negative is on the left side. But if I have it here, that means I'm going to -2 from the left side. And if it's positive, that means I'm approaching -2 from the right side.
I'm sorry, what does the negative in front of the number mean?
Oh, that's just a regular -2 versus +2.
Okay.
Yep, that's just the regular sign that you normally see. I just wanted to emphasize the fact that this negative that we're talking about will be on the right side of your number. This is the new, the new negative that we're talking about now.
Okay.
Mhm. All right, is that okay? Can we look at the example? I think some questions come. Yeah. Okay. Do this. All right. So let's say if this is our graph and they ask us, what is and this graph represents f of x. This represents our function, everything that's going on in this graph. So if they want to know what is the limit, if you look at the first one, what is the limit of this function as x goes to 2 from the left side? So the question they're actually asking is, what is so basically you want to know what is y as x approaches the value. So if we're looking at 2, 2 is right here. So as x approaches 2 from the left side, what is y? Y is going to be 1. All right. So what is your y value when you go up here? You know, to this point, y is 1. Then it says when x, what is the limit as x approaches 2 from the right side? Well, from the right side, it goes down here, but this is 2. It's still going to be 1 because this is what y is at this point, because both of them come down to the same point, which is 1. All right. Now, this third one, notice the difference in what's going on here. It's not asking you about the limit. It says when you plug 2 into the function, what do you get? And notice there's an open circle right here. So at 2, the function does not exist right there at 1. It exists up here at y equal to 2. So you do have to be careful with open circles versus closed circles, and also be careful with if they're asking you about a limit, or if they're just saying when I plug 2 into my function, what am I getting out? So they're going to play with the symbolism and make sure you're paying attention. And I didn't have f of x right here. All right. Then this last one. I don't know if it's the last one. Yeah. This is your general limit. So don't forget that. And we had already established it going to 2 from the left side and going to 2 from the right side. Both gave us 1. So that means the general limit has to be 1 as well. And you can see that they both go down to the same point, which is right here, which is y equal to 1. So remember, when you talk about limits, we're talking about how does the function behave, you know, going not necessarily where does it exist. You look at how the graph behaves, they're going towards 1, y being equal to 1 when they go towards 2. Questions on any of that? Make sure we're okay. As a matter of fact, yeah, let me do this. All right, so just to make sure we're okay with this, if we look at this function as x goes to 1 from the left side, so x being 1 is right here, and coming from the left side, we're going right here. And if we look at this point, that means at x equal to 1, y is 0. So this actually would be 0. All right, coming from the left side. Now, if we were to do this other one, what is the function? The limit of the function is x goes to 1 from the right side. Notice it comes this way. And the y value for this point is actually 1. All right. So that means, you know, since the going to 1 coming from the left side is 0, going to 1 from the right side is 1. That means the general limit as x goes to 1 does not exist because each have 2 different points. They're going to 2 different points. So all right. So because they're going to 2 different points, that means the general limit as x goes to 1 does not exist. All right. Can I scroll up? Everybody good? Okay, so here is a relationship that you do need to hold on to, the limit of theta as the limit of sine theta over theta as theta goes to 0 is going to be equal to 1. So there's going to be different ways that they manipulate, or we're going to be able to use this relationship to manipulate different limits that we get. So if you have sine of something that's over that same thing and theta is going to 0 or x is going to 0, that is going to be equal to 1 for us. So we're going to look at different ways of using that relationship to our benefit. So a quick example of that is right here. We have the limit of sine 2x over 2x as x goes to 0, and that is going to be equal to 1 for us. Notice what is sine and what is being applied by sine. Not what is sine, what sine is being applied to and what's under sine of that is going to be the same thing. So that's why we have 2x here and 2x here. As long as we have that relationship, the limit is going to be 1. And of course, your variable has to be going to 0. All right. All right, looking at this next one, we have 2 sine of the square root of 10 theta over the square root of 10 theta. So we can look at this problem. And of course, theta is going to 0 once again. So we can look at this problem really like this, separating that quantity, that relationship that we just established here. And do I want to put it up? Yeah, and we can look at it this way. Now, whether you write this out or not a big deal, but the way you will look at it. So since 2 is a constant, you can actually pull that to the outside since it doesn't have a variable, because the limit of that as theta go to 0 is just going to be 2. So now if you just look at this part right here, that's going to be 1. And so the answer would just be 2. All right, next one, we have the limit of sine of 11y over 9y as y go to 0. So what we need is 11y in our denominator. We have 9y in our denominator, so that's not going to necessarily help us. We need y, but we need an 11 down there. So what we can do is, I don't know why I did this, is multiply both top and bottom by 11. So doing that, let me see, do I want to write this a little better? Let me do this. So we're multiplying both top and bottom by 11. All right, and so now what I would do is pull the 9 out and attach the 11 to that y. You know, it's all commutative, so you can move your terms around, just multiplication. Do this a bit. Widen it. I just want to clean this up. All right, so we have 11 times sine 11y over 9 times 11y. And just like with that 2, bring that 11 over 9 to the front and just apply the limit. Sine 11y over 11y. That'll be 11 ninths times 1, which is 11 ninths. All right. Any questions on what we did there before we look at another one? All right. So the next one, looking at the limit of 7y over 6 tan y as y go to 0. So now this relationship that we're talking about involves sine, not tangent. So if we can rewrite tangent involving sine, that would be to the best, to our benefit, because we can use that relationship that we just finished talking about. So don't forget that tan or tangent is the same thing as sine over cosine. Cotangent, same thing as cosine over sine. They're inverses of each other. And so 1 over tangent is actually cotangent. So manipulating this problem here, what I decided to do was to bring the 7 over 6 to the front. And I have my y, which is going to be a part of, my manipulation of the problem. And that's times 1 over tangent. So I just broke up everything so I can manipulate it. So like I just mentioned, 1 over tangent is cotangent. They're inverses of each other. So that's what I did here. Cotangent is cosine over sine. So that's what we did here. Just rewrote cotangent. All right. So then I broke it up, in which I took the cosine, just reverse flip the positions, switch the positions of the cosine and y, because all of this is multiplication, so you can move things around, as you like. 5 times 2, 2 times 5 is still 10. So as long as it's all multiplication, you can move the things around, your terms around. So I just switched the positions of my y and cosine y. And so here, just re-emphasizing how this helps us. So we know that the limit of sine y over y as y go to 0 is 1. But also the limit of y over sine y as y go to 0 is also 1, because 1 to the negative first power is 1. You know, the inverse of 1 is 1. So either one of these relationships will give us 1. And that's what we have right here. All right, so apply the limit to all of this. The 706 is not affected. Plug in 0 for cosine y, so it's cosine 0. And then we already said this relationship is going to go to 1 for us. And then cosine of 0 is 1. So that's 7/6 times 1, which is 7/6. So notice that one leaned on your trig identities. No, I have a copy of the trig identities somewhere, so I'll try to send that to you just in case you haven't seen them in a while. But yeah, matter of fact, most of you should have, because no, did we get that far? I forgot. I think we did. No. Anyway, I can send you a copy of your trig identities. And remember, we decided to change tangent to cotangent so that we can get that that relationship of sine out of that, so we can use this here. Oh, my pen not working. Okay. All right. Can I go to the next one? All right. Same thing going on here. We have the limit of x cosecant of 6x over cosine of 8x as x goes to 0. So once again, we have to figure out how can we use this relationship of sine in this problem, or how can we pull it out? How can we, convert something to sine so that we can use the relationship that we just finished talking about? So cosecant is the inverse of sine. So cosecant is equal to 1 over sine x, and secant is equal to 1 over cosine. So probably don't need to use that, but I was just throwing it out there just to make sure, if anybody didn't know. So let's manipulate this problem. We leave x to where it is. I brought out 1 over cosine 8x, and then we have cosecant 6x in the numerator. So we're going to use this relationship right here to flip that cosecant into sine. So there'll be 1 over sine 6x. So now I have a 1 up here, but I need a 6. Because remember, whatever is being applied right here, I need to be right here. So now I have an x up here, but I don't have a 6. So I'm going to multiply. Let me erase this stuff. If I can erase it. So I'm going to multiply top and bottom by 6, like I did before with that 11. And I'm going to use, and I left my eraser on. I'm going to use this 6 and this x and place it right here. Because remember, once again, this is all multiplication. So I'm just moving stuff around. As long as it's all multiplication, I'm still good to do stuff like that. So I took the 6x, put it over there in the numerator. Hey, I left my eraser on again. Put it in this numerator, and then I took this 6 and just put it in front of the cosine 8x that's in the denominator. So now we have the limit as x goes to 0 of 1 over 6 cosine 8 times 0, because you're plugging in 0 for that. And then here, this goes to 1 because of our relationship with sine. All right, any problems, any problems? Some things may not come up, or some questions may not come up until you actually get in there and try it on your own. All right. So we have 1/6, and then the cosine of 8 times 0, which is 0. Cosine of 0 is 1. So that's what we got right here, cosine of 1. I mean, cosine of 0 is 1. So that'd be 6 times 1. And then we just said that this quantity turns into 1 when you apply the limit. So we have 1/6 times 1, which is just 1/6. Almost finished, almost finished. Then we got like one more. Any questions before we look at this next one? All right, let's see. I think this is our last one. Yep. All right. So we have the limit as y go to 0. Let me erase this. Of y squared minus 8y plus 4 sine of y over 7y. So just like before, I cannot just plug in 0 into this function because 0 in my denominator will occur because of 7 times 0. All right. So what we'll do is try to break this down. We can distribute that 7y into each numerator. So it's y squared over 7y minus 8y over 7y plus 4 sine y over 7y. And then cancel out and reduce where possible. So one of your y's will cancel out here. This y will cancel out here. Nothing cancels out here, of course, because that's sine y, not just a regular y, so we can't cancel out those y's. So now I have y over 7 minus 8 over 7 plus 4 over 7 sine y over y. And so, of course, we separate this piece because that will help us to get 1 when we apply the limit as y go to 0. All right. So this is our expression simplified as much as possible. We have y over 7 minus 8 over y. I mean 8 over 7, excuse me, plus 4 over 7 times sine y over y. So now if we apply the limit as y goes to 0, see here, we're going to plug in 0 for y. There's going to be 0 over 7, which will be 0. Nothing we can do with that. There's just going to be negative 8/7. Put that minus sign stronger. All right, next one is 4 over 7 times. We have the sine y over y, which will turn into 1 once the limit is applied. All right, so 0 over 7, like I said, is 0. Then we have negative 8/7 plus 4/7, which will give us negative 4/7 as our limit. All right. Questions on anything? All right. So that's 2 sections. So we, even though we have a few minutes left or whatever, we don't have to keep going. I think that's a good place to stop. So we covered 3 sections this week. So try the stuff out in Math Lab. See if you have any problems. I'll open up the floor for questions first when I see you on Monday. I'll try to go ahead and generate the lectures from Monday and today. So you can go ahead and have those, shoot that to you this evening. That's the plan. And then we go from there. Any questions or concerns or comments before we close out? Anybody? Okay. But if you guys are good, I'm good. Have a great weekend. Be safe. And I will see you on Monday. Take care.